You know, have you ever stopped to really look at a bird? I mean, a sparrow, a pigeon, maybe even a chicken. We see them every single day. But what if I told you they're hiding an absolutely epic secret? A family history that stretches back hundreds of millions of years. Well, in this explainer, we're going to follow the clues and uncover that secret, piece by piece.
Yeah, I know. It sounds like something out of a movie, right? But the scientific case for it is absolutely rock solid. We're going to walk you through all of it, the clues, the suspects, and the smoking gun evidence that proves the little bird in your backyard is, in fact, a modern-day dinosaur. So our story, our whole investigation, it doesn't start with some big explosion. Nope. It starts with a single feather pressed into a piece of stone. And this one little fossil would spark a debate that lasted for more than 150 years and completely changed how we see life on Earth.
So get this, just 1 year after Darwin published On the Origin of Species, this fossil feather shows up. And right after that, a nearly complete skeleton. They named it Archaeopteryx. And when the famous scientist Richard Owen took a look, it was obvious this thing was, well, bizarre. It didn't fit neatly into any box. It was the perfect scientific puzzle.
And this right here shows you exactly why it was such a head-scratcher. Just look at this crazy mix of features. On the one hand, it's got feathers, wings, and a wishbone. That's all 100% bird. But then you look closer and see a full set of sharp teeth, a long bony tail, and clawed fingers on its wings. That's straight out of the reptile playbook. So it wasn't a bird, and it wasn't a reptile. It was both. A perfect in-between fossil. Okay, so if Archaeopteryx was the link between reptiles and birds, which reptiles are we talking about? Well, the idea that turned out to be right was pretty radical for its time, and it came from one of science's most famous defenders. Let me introduce you to Thomas Henry Huxley. This guy was known as Darwin's bulldog because he was such a fierce defender of the theory of evolution. And when he looked at Archaeopteryx, he was the first person to really connect the dots and say, hey, wait a minute, birds didn't just evolve from any old reptile. They came from dinosaurs. Huxley's whole argument came down to the anatomy. He put the bones of Archaeopteryx side by side with the skeletons of these small, two-legged, meat-eating dinosaurs called theropods, like this little guy, Compsognathus. The similarities in the legs, the hips, the shoulders, they were just too close to be a coincidence. But believe it or not, for 100 years, this idea was still fiercely debated. So for over a century, Huxley's idea was just that, a theory. There was still a huge piece of the puzzle missing. You know, that one undeniable piece of evidence that could finally close the case for good? And that evidence, the smoking gun, was about to be dug up. The 1990s changed everything. Paleontologists in China started finding these incredibly well-preserved fossils. They were unmistakably theropod dinosaurs, but they had a feature that was just shocking at the time. They were covered in feathers. From simple, fuzzy stuff we called dino fuzz, all the way to complex flight feathers. Suddenly, the link wasn't just a theory anymore. You could see it, right there, fossilized in stone. Of course, this amazing discovery opened up a whole new can of worms. Okay, fine. Dinosaurs had feathers, but what did they actually look like? For decades, we all pictured dinosaurs in these boring, muted reptilian colors. But could we ever really know what they looked like? The answer, incredibly, turned out to be yes. Okay, this is where the science gets so clever. It turns out that pigment can actually be preserved in fossils, but you have to look for it at a microscopic level. Scientists found these tiny little structures called melanosomes. Now, here's the key. In living birds, the shape of these melanosomes tells you the color. The long, sausage-shaped ones, they mean black or gray. The little round, meatball-shaped ones, those mean reddish-brown. So by analyzing the fossilized melanosomes, they could literally color in the dinosaurs. How amazing is that? And this quote just perfectly captures that aha moment. As the scientists were piecing together the color patterns of one of these small dinosaurs, they realized it didn't look like some drab lizard. It looked like a modern bird you might see on a farm. And here it is. This is Antiornis, not a dull, scaly monster, but this vibrant, chicken-sized animal with these striking black and white patterns, gray splotches, and a flashy red crest. This was the first time in history we could look at a dinosaur and know, with scientific certainty, what it looked like when it was alive. The old image of the boring gray dinosaur was officially extinct. So the case is closed. Birds are dinosaurs, which lets us ask the next big question. How did it happen? How do you take a theropod dinosaur's body and transform it, piece by piece, into a modern bird that's built for flight?
It turns out recent discoveries have shed a ton of light on this. The transformation from a ground-running dinosaur into a master of the skies involved a whole series of major evolutionary upgrades. We're going to look at 4 of the most critical changes: what happened to the brain, the snout, the flight engine, and the skeleton itself.
First up, the brain. Your typical dinosaur brain was kind of long and small, but on the path to becoming birds, it got bigger and more ball-shaped. The really important part is that the cerebrum and cerebellum, the bits for thinking and balance, they expanded massively. This wasn't just a bigger brain, it was a completely rewired brain, one that was optimized for the incredible brain power and coordination you need to fly.
Next, that iconic dinosaur snout had to turn into a beak. And the key innovation here was something called cranial kinesis. It's a fancy term, but it just means a flexible skull. This turned the rigid dinosaur jaw into a super precise tool. This new beak could move with incredible dexterity. It basically became a surrogate hand for grabbing food, building nests, and fixing feathers.
Right, to fly, you need a powerful engine. For a bird, that engine is its chest and shoulders. The flat dinosaur breastbone evolved a deep keel, kind of like on a boat, to anchor huge flight muscles. The wishbone got stronger and more angled, and, most brilliantly, a complex pulley system evolved in the shoulder that allowed for a powerful upstroke of the wing, something their dino ancestors just couldn't do. And finally, to get off the ground, you have to be light. Dinosaurs evolved a brilliant trick for this: hollow bones. But they weren't just empty. This system, called PSP, meant that air sacs from their lungs actually grew into the bones. This made them incredibly strong but also incredibly lightweight. Birds inherited this system and just perfected it. So what's the result of all these incredible innovations? Just pure success. Today, there are around 11,000 species of birds. Think about that. They are the only dinosaurs who survived the mass extinction 66 million years ago, and they went on to conquer literally every continent and ocean on the entire planet. So we followed the clues from a single fossil feather all the way to the microscopic details of its color. We've traced the incredible engineering that transformed a dinosaur into a bird. The verdict is in. So let's just quickly recap the evidence that cracked this case wide open. We started with Archaeopteryx, our first clue that blurred the lines between reptile and bird. Then, following Thomas Huxley's lead, we identified our prime suspects, the small theropod dinosaurs. The undeniable smoking gun came from those stunning feathered fossils in China, which proved the connection beyond all doubt. And finally, we saw the mechanism, the step-by-step upgrades to the brain, beak, and flight engine that built the modern bird. So I'll leave you with this one last thought. The next time you see a bird, any bird at all, remember you're not just looking at an animal. You're looking at a survivor. You're looking at a branch of the dinosaur family tree that never died out. You are, in fact, looking at a living dinosaur.